This is Lesson 1.7, Functions. Your objectives are to determine whether a relation is a function and to find function values. Relations in which each element of the domain is paired with exactly one element of the range are called functions. To be a function, the x cannot repeat whenever the ordered pairs are written. In an equation, you can't have a y squared. The x cannot be shared in a mapping. A vertical line cannot hit the graph twice. In other words, it has to pass the vertical line test. X equals a number is bad, that's a vertical line. Y equals a number is fine, that's a horizontal line. And if it has f of x is definitely a function. Remember, x goes to only one y in a function. Example 1, determine whether the relation is a function. Well, with the ordered pairs, the x values is what you need to look at. 6, 4, 7, and -3. The x does not repeat, so that's a function. Example 2, is that a function? Well, pass a vertical line through it. Does it ever hit the graph twice? It's fine there, it's fine there, it's fine there. No matter where you put a vertical line, it will only cross the graph once, so that's a function. Determine whether each relation is a function. Well, number 1, we have a graph. Let's do the vertical line test. Does a vertical line ever hit the graph more than once? Once, 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 and once. It passes the vertical line test. That's a function. For number 2, do the vertical line test. Does it ever hit more than once? Once there, once there, once there, once there. No matter where you put it, it only hits the graph once. That's a function. When you have a mapping, check the x values. Does the x ever go to more than one y? And this one does. -1 is shared. You can't have the x shared in a mapping. That is not a function. For number 4, do the vertical line test. Does a vertical line ever hit more than once? It does right there. It hits twice. And there are other places where it fails too. This is not a function because it fails the vertical line test. Number 5, it's a graph. It's a vertical line. That definitely fails the vertical line test. Vertical lines are never functions. Number 6 is a graph. Do the vertical line test. Once there, once there, once there, once there. It passes the vertical line test. That is a function. When you have ordered pairs, check the x values. Do they repeat? 4, 2, and 6. They don't repeat. That's a function. For number 8, check the x values. Do they ever repeat? Yes, they do. -3 repeats. This is not a function. Number 9, the x values do not repeat. This is a function. Number 10, in an equation like this, check for a y squared. There is not a y squared, so this is a function. Number 11, does it have a y squared? Yes, it does. This is not a function. Number 12, x equals -4. When x equals a number, that's a vertical line. This is not a function. You cannot have x equals a number. Find function values. Equations that are functions can be written in a form called function notation. For example, y equals 2x minus 1 can be written as f of x equals 2x minus 1. In the function, x is the domain and f of x is the range. Suppose you want to find the value of the range that corresponds to the element 2 in the domain. this is written f of 2. To find this, substitute 2 for x in the equation. F of x equals 3x minus 4. Find f of 3. For f of 3, substitute 3 for x and work it out. 3 times 3 minus 4 is 9 minus 4, which is 5. For f of negative 2, substitute negative 2 in for x. 3 times negative 2 minus 4 is negative 6 minus 4, which is negative 10. Substitute whatever's in parentheses for the x and work it out. If f of x equals 2x minus 4 and g of x equals x squared minus 4x, find each value. Number 1, f of 4. We'll substitute 4 in for x. 2 times 4 minus 4, which is 8 minus 4, which is 4. 4 is the final answer. Number 3, f of negative 5. Substitute negative 5 in for x. 2 times negative 5 minus 4, which is negative 10 minus 4, which is negative 14. Number 5, f of 0. So substitute 0 in for x. 2 times 0 minus 4. 2 times 0 is 0, and 0 minus 4 is negative 4. Number 7, f of 3 minus 1. Notice the difference. We're going to find f of 3, and then we will subtract 1. So substitute 3 for x, because that's what's in parentheses. And then after you do 2 times 3 minus 4, subtract 1 from that. So that gives you 6 minus 4 minus 1, which is 2 minus 1, which is 1. Be careful with these. If there's something extra or strange, make sure you account for it. Number 9, g of 1/4. G of x is x squared minus 4x. We'll substitute 1/4 in for x. 1/4 squared is 1/16. 4 times 1/4 is 1. And now let's get a common denominator. 1 is the same as 16 over 16. And 1/16 minus 16/16 is negative 15/16. Number 11, f of k plus 1. Be careful here, this one's different too. Substitute k plus 1 for the x. Notice the whole k plus 1 goes in there. Now distribute. 2 times k plus 1 is 2k plus 2, because you do 2 times k and 2 times 1. And then combine your like terms. 2 minus 4 is negative 2. Number 13 is a little bit different as well. F of 3x. So substitute 3x for the x. 2 times 3x minus 4. And 2 times 3x is 6x. And you're finished. Number 15, g of negative 4. Substitute negative 4 in for x. Watch your signs here. Negative 4 squared is 16. And negative 4 times negative 4 is a positive 16. 16 plus 16 is 32. So remember, to be a function, each x goes to only one y. That means the x doesn't repeat, the y can't be squared. It has to pass a vertical line test when it's a graph. When you're taking f of 3 or g of negative 4 like this one, substitute the value in parentheses for the x and then work it out. Make sure your answer is in simplest form.